In late 2019, one of the brightest stars in the night sky began to go out. Over a few months, Betelgeuse, the red shoulder of the constellation Orion, faded to less than half its normal brightness. Astronomers around the world ask the same question. Were we about to watch a star explode? Well, it didn't. And the reason turned out to be stranger than a supernova. Betelgeuse has been hiding a companion, something orbiting inside its own atmosphere, and finding it has rewritten when this star is going to die. Betelgeuse is one of the most recognizable stars in the sky. That distinct orange-red point making Orion's shoulder, about 700 light-years away. It's a red supergiant, a dying star near the end of its life, and it's colossal. If you dropped it where our sun sits, it would swallow Mercury, Venus, Earth, Mars, and reach out toward Jupiter, roughly 1,000 times the width of the sun. For a century, astronomers watched it pulse and flicker, brightening and dimming on a slow rhythm nobody could fully explain. Then, in 2019 came the big one, the Great Dimming. And in July 2025, after years of suspicion, astronomers finally confirmed what was hiding in the data. Betelgeuse as a companion star. To understand why that dimming caused such an alarm, you have to know what stage Betelgeuse is in. As a red supergiant, it's burned through the hydrogen in its core and swollen to enormous size as it works through heavier fuels. Stars like this are in the final acts of their lives. When one runs out of fuel for good, its core collapses and it detonates as a supernova, one of the most violent events in the universe. So when Betelgeuse, a star already known to be near the end, suddenly lost more than half its light, it was reasonable to wonder if the countdown had begun. Some studies even suggested it could go within a matter of years. For a moment, the dimming looked exactly like a star starting to die. The companion is named Siwarha, and it's a modest star, about 1.5 times the mass of our Sun, looping around Betelgeuse once every 6 years or so. The team that confirmed it, led by Andrea Dupree at the Center for Astrophysics, used the Hubble Space Telescope and ground-based observatories to catch not just the star but the trail it leaves behind. The idea that Betelgeuse had a hidden companion had been floating around for years. Hints kept surfacing in its motion and its light, but nobody had ever seen it directly. It sits right next to a star thousands of times brighter, so pulling its faint glow out of that glare is extraordinarily hard. Catching it at all was a feat, and Siwarha doesn't orbit at a safe distance. Its path takes it straight through Betelgeuse's vast, puffed-up outer atmosphere. As it plows through that gas at about 40 kilometers per second, it leaves a wake. Picture a boat cutting through water, dragging a churned-up trail behind it. That wake of dense gas spreads across the face of the star, absorbing and scattering its light. Over about 3 years, it builds until it covers much of the disk, and Betelgeuse dims. Then it disperses, and the star brightens up again. That's the slow, 6-year rhythm that puzzled astronomers for decades. Not a dying star, a companion steering the pot. And once you know the dimming isn't a death rattle, the whole timeline from when Betelgeuse explodes falls apart and gets pushed much, much further away. Before the companion was found, some estimates leaned on Betelgeuse's erratic behavior as evidence it was close to the end. A 2023 study raised the possibility of an explosion within tens of years. But if that behavior is mostly Siwarha's doing, the urgency evaporates. The current picture is that Betelgeuse is in a stable helium burning phase, still fusing fuel steadily, not staying on the brink. The revised estimates push the supernova out by 100,000 years or more. Part of the reason astronomers can be fairly confident it's not imminent is that the very end comes with unmistakable signs. In its final stages, a star like Betelgeuse burns through progressively heavier elements, carbon, then neon, oxygen, and silicon, each stage faster than the last. That final silicon burning phase lasts only days before the core collapses. A star in that state would be pouring out energy in ways we could detect. Betelgeuse isn't. By every measure we have, it's still in the slow, stable middle of its old age. And the great dimming of 2019 itself turned out to have more ordinary explanation. Betelgeuse ejected a huge cloud of dust, which drifted across our line of sight and blocked part of the star's light. A one-time event, layered on top of the companion's slower rhythm. A star sneezing, not a star dying. So despite the rumors that resurface every year, there's no credible evidence that Betelgeuse is going supernova in 2026 or anytime soon for that matter. But, and this matters, none of this means Betelgeuse is safe forever. It just means we were reading the clock wrong. Betelgeuse will explode. That part was never in doubt. It's a massive star in the last stage of its life, and when it finally runs out of fuel, its core will collapse and it will erupt as a Type II supernova. The kind that comes from a single giant star caving in on itself. When it happens, it will be the brightest stellar explosion in recorded history. It would shine about as bright as a crescent moon, blaze in broad daylight, cast shadows at night, and stay lit for months before slowly fading over a year or more. And when the light finally dies down, it will leave something behind, a city-sized core, crushed by gravity into either a neutron star, a sphere so dense a single teaspoon of it would weigh billions of tons, or just possibly a black hole. And it won't hurt us. For a supernova to seriously threaten life on Earth, it would need to go off within about 160 light years. Betelgeuse is more than 4 times that distance away. We get the spectacle with none of the danger. A front row seat to a star's death, from a safe remove. Siwarha won't be so lucky though. When Betelgeuse finally detonates, the small companion that's been quietly shaping its light for centuries will almost certainly be swallowed in the blast. There's a lot we still can't pin down. 100,000 years is an estimate, not a promise. Predicting exactly when a specific star will explode is something astronomy still can't do precisely. It could be far longer. In principle, it could be sooner. The honest answer is that we don't know the date, only that it's almost certainly not in our lifetimes. And if it ever does happen, we'll get a warning no telescope could give. The first sign of a core collapse isn't light. It's a burst of ghostly particles called neutrinos, which pour out of the dying core and escape hours before the explosion breaks the star's surface. Detectors buried deep underground around the world are standing ready to catch that signal. When Betelgeuse goes, the neutrinos will reach us first. What we'll get sooner is another look at the companion itself. Right now, Siwarha is stuck behind Betelgeuse from our point of view, hidden. Around 2027, it's expected to swing back into view, and astronomers are already planning to watch the wake form again in real time, to test whether this whole picture holds. For a few moments in 2019, it looked like we might witness the death of a star in our own sky. Instead, we found something quieter, and it's way more remarkable. A giant star with a hidden partner threading through its atmosphere, painting patterns in its light that fooled us into watching for the end. Betelgeuse will die, just not yet, and not the way the panic suggested. For now, it keeps burning at Orion's shoulder, a small companion carving its way through the dark, and a front row seat held open for whenever the real show begins. If this one was worth your time, a like genuinely helps the channel grow. This channel is about exactly these moments, when something we thought we understood turns out to be stranger. Subscribe if that's your kind of thing. Thanks for watching. Clear skies.